This video is for Chemistry in the Earth System, Unit 4.1, Chemical Reactions and Equations. Today's essential question is, what are 5 types of chemical reactions? Our main idea, classifying reactions into 5 types. Even for relatively mundane purposes, we might want to be able to predict the reactions that occur when 2 substances are put together. We know, for example, that it is safe to combine bleach and detergent in the washing machine. But is it safe to mix bleach and an ammonia-based cleaning product? Hint, no it's not. We know that adding baking soda to batter will help give a cake the shape and texture that we want. Rather than try to memorize all the chemical reactions that are possible, it makes sense for us to find patterns that help us predict reactions. Chemists classify reactions into categories based on the behaviors of the chemicals involved. By understanding the different types of reactions, scientists can predict the outcome of almost any combination of chemical substances. Our first type, synthesis reactions. A synthesis reaction occurs when 2 or more reactants combine to form a single product. This type of reaction is represented by the following general equation. A plus B reacts to yield AB. A and B can be elements or they can be compounds, but AB is a compound. To demonstrate a synthesis reaction, you can use a balloon filled with a mixture of hydrogen gas and oxygen gas. When a flame comes into contact with the balloon will burst. However, the bang is much louder than that of just a popped balloon. The hydrogen and oxygen in the balloon react to form water. And in this reaction, hydrogen and oxygen are the reactants, or the starting materials. Water is the product. This chemical reaction is represented by the following equation on your screen here. Decomposition reactions. In a decomposition reaction, a single compound undergoes a reaction that produces 2 or more simpler substances. The products might be elements or less complex compounds, or a combination of elements and compounds. This type of reaction is represented by the following general equation. AB reacts to form A plus B. Again, A and B can be elements or compounds, but AB is a compound. To release hydrogen for use as fuel, chemists use electrical energy to break down water into its constituents, hydrogen and oxygen. This reaction, which is the reverse of the synthesis reaction demonstrated on the previous slide with regard to the balloon, is represented by the following equation that is on your screen here. 2 waters react to form 2 hydrogens and 1 oxygen. Most decomposition reactions only take place when energy, such as heat or electricity, is added. The process of using an electric current to initiate and to drive a reaction is called electrolysis. Combustion reactions. During a combustion reaction, an element or compound rapidly combines with oxygen to form an oxide. This reaction releases heat and light. The flame of a Bunsen burner represents a combustion reaction. Methane, which is CH4, supplied to the burner, reacts with oxygen in the air, and carbon dioxide and water are produced. Each of these products is an oxide. Combustion reactions are commonly used in heating, cooking, and transportation. This reaction is represented by the following equation that is on your screen here. Some synthesis reactions can also be categorized as combustion reactions. The combustion reaction between hydrogen and oxygen is also a synthesis reaction. Hydrogen combines with oxygen to form an oxide, which is water, and the reaction releases thermal energy. Single displacement reactions. The final 2 types of reactions that we're going to cover here are displacement reactions. They are also called replacement reactions because atoms or ions in the reactants are replaced with other elements. A single displacement reaction is a type of reaction that occurs when an atom or ion within a compound is replaced by a similar atom or ion. Single displacement reactions can be represented by the following general equations. A reacts with BC to form AC plus B. For metals, a single displacement reaction will occur if the element being replaced is lower in the reactivity series than the element that will take its place. When copper is placed in an aqueous solution of silver nitrate, two visible changes occur. The copper metal becomes covered with crystals of silver metal, and the solution becomes blue. This reaction is an example of a single displacement reaction. In this case, the more active metal, which is copper, is replacing the less active metal, silver, in the solution. This reaction is represented by the following equation on the screen here. Copper reacts with silver nitrate in solution to form silver plus copper nitrate, again, in solution. By conducting tests using combinations of elements and compounds, chemists have developed a list to predict when single displacement reactions will happen. A reactivity series, sometimes referred to as an activity series, lists elements from the most active to the least active. In the example of copper and silver nitrate, the silver cations in the solution are reduced, which means they gain electrons and become silver atoms, no longer ions. The blue color of the solution is caused by the presence of copper-2 cations. Some copper atoms in the metal are oxidized, which means that they give up electrons and become copper-2 ions. Silver, Ag, is located below copper, Cu, in the reactivity series. So, in this single displacement reaction, the copper atoms replace the silver ions in silver nitrate. The most active metals, such as those in group 1, react vigorously with water to replace hydrogen in the water. Less active metals, such as zinc, require the water to be in the form of steam for this reaction to take place. The reaction types can be represented by some of the following reactions, including the one at the top of the screen here. In a different type of single displacement reaction, one halogen replaces another halogen in a compound. Fluorine is the most active halogen, so it will replace all other halogens in their compounds. Each halogen is less active than any halogen above it on the periodic table. This reaction type is represented by the following equation. We have chlorine gas reacting with potassium bromide, and the chlorine replacing the bromide, and then we have bromine liquid replacing the chlorine, but not. You see that on the screen here, there is no reaction because chlorine is above bromine on the periodic table and in the reactivity series. So it will not replace chlorine. Double displacement reactions. In a double displacement reaction, the ions of two compounds exchange places and form a new compound. This means that the cations and anions trade places. Double displacement reactions can be represented by the following general equation. AB plus CD reacts to form AD plus CB. For example, a sodium chloride solution is composed of sodium ions and chloride ions dissolved in water. A silver nitrate solution is composed of silver ions and nitrate ions dissolved in water. When the two solutions mix, the ions collide with each other. Sodium ions and nitrate ions remain dissolved because sodium nitrate is soluble. However, when silver and chloride ions collide, they bond together to form a precipitate. This reaction is represented by the following equation on your screen here. Solubility describes how readily a substance dissolves in water. Solubility rules help scientists determine whether an ionic compound will be soluble or insoluble. The formation of a precipitate when two solutions are mixed is often a sign that a double displacement reaction has occurred. The formation of the compound, water, or a gas are also signs that a double displacement reaction has occurred. Reactions between acids and bases are also a type of double displacement reaction. When acids and bases react, the products are usually water and a salt. For example, when hydrochloric acid reacts with sodium hydroxide, the products are the salt sodium chloride and water, according to the equations on your screen here. Oxidation-reduction reactions. Oxidation-reduction reactions, also known as redox reactions, are reactions in which one element loses electrons, or is oxidized, while another gains electrons, or is reduced. This is a different way of classifying reactions, so many reactions can be classified as both a redox reaction and another type of reaction that we've already covered. For example, single displacement reactions and combustion reactions are also redox reactions. Many synthesis and decomposition reactions are also classified as redox reactions. At this point, you should be able to generate a full and appropriate response to today's essential question. What are 5 types of chemical reactions?